powers. So this is radical lesson number 3, simplifying radicals with odd powers today. So yesterday was even. Today is going to be odd powers. So we know that even powers are all perfect squares. Any even power I see under a radical, I can just take half of it and I will get my square root, right? But when I have an odd power under a radical, that kind of changes things. We have to do one little step before, and basically what we want to do is turn these odd powers into even powers. So let's picture every odd number on the number line. Every odd number is only one space away from an even number, right? Either left of it or to the right of it. So if you're at 7 and you go down, you're at 6, or you go up, you're at 8, okay? So what we're going to do is we're going to break x to the 7th down into an x and an x to the 6th, right? Because I can. Because if my answer is x to the 7th, we know that all I have to do is add the exponents. X to the 2nd times x to the 5th would work also, but then that still leaves me with an odd. So what I want to do is always go one less and then with a 1. And so now, isn't that not an even power? Which means it's a perfect square, which means I can pull an x to the 3rd out, but I'm left with an x at the end. Okay? If I have an a to the 11th, and I want to know the square root of that, I look at it, I see that it's odd. I don't make it a to the 5.5. You don't do that. You only do that for even powers. You make this the square root of a times the square root of a to the 10th, bless you. And now you have an even power. This a will never be able to come out. Why? Because it's odd. It's a 1, and it can't come out. It's not a perfect square. But this can, and that's a to the 5th with the square root of a left. So you're kind of starting to see what's happening. With odd powers, you're always going to have 1 left over. So let's take y to the 21st. And if I want to know the square root of that, I need to break it down into the square root of y and the square root of y to the 20th. So go ahead and give that a shot. See what you get. Okay? Easy enough? Okay. Now, that is the basis for how this lesson starts. But of course, we always build on those concepts, right? So that's the building block. So let's make it a little trickier, because we're going to add about 4 or 5 levels to these. And by the end of the hour, you're going to be doing problems like this. But you're going to do them, and you're going to be like, holy cow, I got it right.
It's fun.
It does. And actually, you know what's so funny is that radicals is my favorite lesson to teach, because it is, I don't know, I find it fun, and everybody's looking at me like, you're strange. So, are you ready? Let's try this. Let's start it simple. Let's take the square root of 49, a to the 13th. Well, the dilemma is 49 is a perfect square, but a to the 13th isn't. So do you remember what I said for your whole first step is? It's setting things up. Don't take any perfect squares yet. Don't take, or any square roots, just set it up, which means separate. So we're going to give this its own little radical. That a to the 13th gets broken down to a and a to the 12th. And once your whole problem is set up, then you go through and slash or circle, right? Slash means take it out because it's a perfect square. Circle means keep it in. It's not going anywhere. Oh, that just rhymed. Square root of 49 is 7. A has to stay in. I really want you to get in the habit of circling it. You'll know why in a minute. And the a to the 12th is a perfect square with that square root of a left over. Got it? Okay. Let's do the square root of 81, x to the 4th, y to the 3rd. So I want to know the square root of that. Yes, I do realize that 81 and x to the fourth are both perfect squares, but we still have one that's not a perfect square. So we have to kind of be patient here and do a y and a y squared, right? So the square root of 81 is 9. Square root of x to the fourth is x squared. Y stays. This y comes out. And half of 2 is 1 with 1 left in. Okay? So now let's do this one. 16 x to the 7th, y to the 6th, z to the 25th. Set it up. This has got to stay. Don't pull that 4 out just yet. 7 gets broken down into x and x to the 6th, right? Z to the, or y to the 6th is okay as it is, so it's just going to kind of come along for the ride. And then z to the 25th is a z times a z to the 24th. And I purposely put that 25th because I wanted to tempt you to take out and make it a z to the 5th. So hope you weren't thinking that, right? Yes, that's what you have to do. You have to identify the odds and immediately separate them into one less and then one. So now I go through and I slash a circle. I take out the perfect squares and I leave in what's not. This is 4. X stays. All single variables will always stay. X to the 6th has a square root of x to the 3rd. Y to the 6th has a square root of y to the 3rd. And for the first time, we have 2 circles. I'm going to show you what we do with that. You probably can guess. Z to the 24th has a square root of z to the 12th. And now, what's left in the circles? An x and a z. And I want them both under the same radical sign. So do not keep them separate. Just whatever's under the radical, all gets put under the radical. So here's what you're doing when you're simplifying radicals. You're looking for what perfect squares can come out and go in front, and what has to stay in and go in behind. Okay? That's what we're doing. So now we have to talk about what happens when that 16 or 81 or 49 is not a perfect square. And I bet you can guess, right? So let's start with the square root of 20. A to the 26th, y to the 13th, z to the 11th. So I was nice. I gave you one perfect square. Okay. So the first step is to set it up. So break down whatever needs to get broken down. And I see all these heads down because you're probably already doing it. Because you know that 20 gets broken down into what? Not 2 and 10. That does me no good. The square root of 4 times the square root of 5. Is a to the 26th okay for right now? Yes. Bring it down for the ride. Y to the 13th gets a y and a y to the 12th. And your z to the 11th gets a z and a z to the 10th. Okay? And if you use this procedure and you set it up, and instead of trying to pull out all the perfect squares at once, or in the beginning, do it all at once. So this is 2. So you can work through that quietly as I do this up here and then check it when you're done. Okay, do you have that as your coefficient? Every exponent counts. This is what's important in this lesson is the exponents. Are you getting the exponents right? A to the 13th, y to the 6th, z to the 5th. But what is all left over? A 5, y, z. Okay? It looks crazy, but it really is not that hard, is it? Okay, if you follow these procedures. Now, I will say this. Some people every year will try to not, like, imagine if those slashes in those circles weren't there. When you go to look back after you pulled all these out, how would you know which ones go in the radical and which ones don't? So really focus on trying to get that circle there because it really helps visually prepare you for what's next. So 32, x to the 7th, y to the 16th. Let's try this. You're really going to start to get comfortable with finding bigger factors because 8 and 6 is not going to do you any good. I mean, it will if you want to do a bunch of extra work, but so start by dividing that bigger number, which I know it's not huge, but by 2. And what's half of 32? So I want you to try this one right now. Forget that negative. Good. What you guys got? Okay. If that's what you got, then we are ready for the next level. Are you ready? Okay. So let's take the square root of 48, x to the 5th, y to the 3rd, and z to the 100th. Now, that looks like any other problem we've done, but now I'm going to add a 2xy to the 3rd on the outside. And this is exactly what we did. If you pretend like none of these x's and y's were there, didn't you do 2 square root of 48? Didn't you just break down 48? But what did you do with the whatever you pulled out? You multiplied it by the 2, right? So, look what's going to happen. I'm going to take that 2xy to the 3rd, and it's going to sit and wait patiently because whatever gets pulled out gets multiplied by that 2xy to the 3rd. So now you just do the problem like we've been doing all the other ones. You're going to start to know that 3 times 16 is 48, right? If you want to go through all those extra steps, you go for it, but I don't. 3, 16. You're going to find also that if you don't start all the way at the left of your page, then you're going to probably run out of room because these start to get a little... Okay, I want you to check out my first step and see if you're okay with it. Because we got to go in order and make sure you're good. Bring this down again. Yep, everything that comes outside of the radical. So the 3 will stay. The 16 will come out as a 4. The x to the 4th will come out as an x squared.
Wait, why does the 3 stay?
Because it can't be broken down any further, yep. Because it's as simple as it's going to get. And so now I look back, my eyes immediately go to the terms that are circled. And what's circled is a 3, an x, and a y. And I'm almost done. I have to go back to chapter 8 where we did our exponent rules. And what does that say when you have the same base? You multiply the coefficient and you add the exponents, right? So this is 2 times 4 is 8. 1 plus 2, don't forget that that's a 1, is 3. Yep. 3 y's here and 1 there is 4. And then no more z's over here. And then 3xy. And it looks crazy, but did you follow it? Okay, it's not that bad. Want to try one last one on your own, like completely on your own? All right, from start to finish, this is you. Oh, I'll just make it interesting. I'll add a little negative there. Okay. At your first step, in that exact order, this is going to hang out here for a little bit. Multiply it by a 2. An a to the third. Good so far? I added that negative in there last minute. I don't know if you got it or not. Thumbs up. It's not that bad. It looks way more intimidating than it really is. So,